Imagine a human species stronger than us, bigger muscles, thicker bones, a brain that was, in some ways, actually larger than ours, built for survival, adapted to freezing ice age climates, capable of hunting animals far more dangerous than anything we face today. This wasn't science fiction. This was a real species that walked the Earth for over 300,000 years, far longer than modern humans have even existed. They're called Neanderthals, and for a long time they thrived. They survived brutal winters. They hunted woolly mammoths. They made tools, controlled fire, and even buried their dead with what looks like genuine care and ritual. By almost every measure of raw physical survival, Neanderthals should have outlasted us. So here's the question that has confused scientists for decades. If they were this strong, this adapted, this successful for so long, why did they suddenly disappear around 40,000 years ago? And here's the part that makes this mystery even stranger. They didn't vanish because of some sudden disaster. There was no single asteroid, no massive volcano, no instant extinction event. Instead, something slower, quieter, and in some ways far more unsettling happened. At the exact moment Neanderthals began to decline, another species was expanding rapidly across the very same land. Us. Modern humans arrived in Neanderthal territory, and within a relatively short period of time, geologically speaking, Neanderthals were gone. Coincidence? Most scientists don't think so. But the real explanation isn't as simple as one group being smarter or stronger than the other. The truth involves climate, competition, disease, and something even more surprising, something written directly into the DNA of billions of people alive today, including possibly you. Stick with me, because the disappearance of the Neanderthals might be one of the most important survival lessons in all of human history. For years, the popular explanation was simple. Modern humans were smarter, and Neanderthals were slow, primitive brutes who simply couldn't compete. But newer research has completely destroyed that outdated idea. Neanderthal brains were, on average, actually slightly larger than modern human brains. They made sophisticated tools, used complex hunting strategies, and even created jewelry and symbolic art, activities once thought to be uniquely human. So intelligence alone doesn't explain their extinction. The real story is far more complicated, and it starts with population size. Genetic studies suggest Neanderthal populations were always relatively small and scattered, living in isolated groups across Europe and parts of Asia. Small populations are dangerous in evolutionary terms because they lead to lower genetic diversity, making a species more vulnerable to disease, environmental changes, and inbreeding-related health problems. Modern humans, on the other hand, arrived in larger, more interconnected groups, with wider social networks stretching across vast distances. This mattered enormously, because larger, more connected populations share knowledge faster, adapt to challenges more efficiently, and recover from setbacks more easily. Imagine two villages facing the same harsh winter. One village has 10 people with no outside contact. The other village has hundreds of people spread across a wide trading network, sharing food, tools, and survival knowledge. Which one is more likely to bounce back from disaster? This difference in social scale may have given modern humans a crucial, quiet advantage, one that had nothing to do with raw strength or intelligence, and everything to do with numbers, connection, and cooperation across long distances that Neanderthals simply didn't have in the same way. Climate change also played a brutal role in this story. Around the time Neanderthals began declining, Europe experienced dramatic and unpredictable climate swings, sudden shifts between extreme cold and slightly warmer periods happening repeatedly over relatively short timeframes. This kind of instability is devastating for any species, because it constantly disrupts food sources, forces migration, and puts immense pressure on already small, spread-out populations. Neanderthals were incredibly well adapted to stable, cold Ice Age environments, but rapid, unpredictable climate swings meant the specific conditions they thrived in kept shifting beneath their feet. Modern humans, having evolved and adapted across many different climates in Africa before migrating into Europe, may have simply had more built-in flexibility to handle unpredictable environmental changes. But climate and population size alone still don't complete the picture. There's a darker possibility that scientists take very seriously today: disease. When modern humans expanded into Neanderthal territory, they likely brought new pathogens with them. Diseases their bodies had built up some resistance to over generations, but diseases Neanderthal immune systems had never encountered before. This is a pattern history would repeat devastatingly later on, When European explorers unintentionally wiped out massive portions of indigenous populations in the Americas through diseases their immune systems simply weren't prepared for. Some researchers believe a similar, quieter version of this tragedy may have unfolded between modern humans and Neanderthals, an invisible biological war fought not with weapons, but with microscopic invaders neither species could see or understand, spreading silently through contact, shared hunting grounds, and overlapping territory during a time when both species were already struggling to survive dramatic climate pressures. Here's where the story takes its most surprising turn. Modern humans and Neanderthals didn't just compete or clash, they also interbred. Genetic studies of ancient DNA have confirmed that modern humans and Neanderthals had children together, multiple times, in different regions over thousands of years. This means Neanderthals never fully disappeared in the way most people imagine. Instead, they were slowly absorbed into the growing modern human population through interbreeding, generation after generation, until distinct Neanderthal populations simply stopped existing as a separate group. Today, most people with European or Asian ancestry carry somewhere between 1 and 2% Neanderthal DNA, quiet genetic echoes passed down from these ancient encounters tens of thousands of years ago. Some of this inherited DNA still actively affects modern humans today, influencing things like immune system responses, skin pigmentation, and even sleep patterns. In a strange, almost poetic way, Neanderthals aren't entirely extinct. They live on, scattered in tiny genetic fragments inside billions of people walking around right now, completely unaware they're carrying pieces of an ancient species that once ruled the same land their ancestors eventually took over. This blending of populations complicates the entire idea of extinction itself. It wasn't purely a story of one species defeating another through violence or superior intelligence. It was a slow, messy combination of shrinking population size, unstable climate, possible disease, and quiet genetic merging, spread out across thousands of years, far too gradual and complex for any single dramatic explanation,